to our weather coverage, and you know we only bring in the big gun on the story when things are really looking terrible out there. Chief Meteorologist Matt Zaffino joins us now. Matt, the National Weather Service has us under an ice storm warning. That does not sound good.
It is not good, and the interesting thing about this, well, there's a couple things, but the expiration time for the ice storm warning in the Portland area, it's not until 4 a.m. on Wednesday morning, okay? But farther down the valley, it expires much earlier. This one expires at 10 p.m. on Tuesday night. So that's a good 6-hour difference. You may wonder, why does it expire so much earlier here than it does in the Portland area? Well, they're going to get warmer and get above freezing sooner than we will. And that, of course, plays into the whole freezing rain forecast thing. And, of course, what we had on Saturday was sleet. So
I was going to ask about that. The difference, why sleet then and freezing rain now?
Yeah, exactly. And the reason is the depth of the cold air and the depth of the warm air, too. So let me explain, because it gets a little complicated, but it's interesting. All of our precipitation in the northern hemisphere, basically, is certainly in the mid-latitudes, begins as snow, even in the summer. And then it melts and it turns into rain. And, of course, once you get below the melting layer in a normal atmosphere, it's rain all the way down because it gets warmer as you get lower. But in the wintertime like this, we get inversions, which means the atmosphere gets a little upside down, meaning that it's colder down low, and then there can be a layer of warm air above that. So when we get a freezing rain situation, cold, snow, melts into rain in this warm layer, but then right at the surface, there's this shallow layer of below freezing air. That's where we are right now. That's where we're going to be for the next couple of days. So the rain, as it falls into that sub-freezing air, because that layer is so shallow, it doesn't have time to refreeze into sleet or ice pellets. So it hits the ground as a liquid, but of course everything's below freezing, so it freezes, and that's when you get that glaze ice, that layer of ice on things, Pat, that is just so terrible and so nasty and so difficult to deal with. Now, on Saturday, it was a sleet situation, and notice the difference here. With freezing rain, thick layer of warm air, thin layer of cold air at the surface. With sleet, thin layer of warm air, thick layer of cold air at the surface. So you get partial melting in that warm layer, partial melting, not complete, and then it falls back into sub-freezing air. So those wet, messy, partially melted snowflakes freeze into ice pellets or what we call sleet. So that's the difference there. And of course, if the atmosphere is cold all the way to the surface, then you just get snow. Now, let me put some numbers to this for you, because I found this super interesting. This is back on Saturday. Parkdale, 1,700 feet, pretty low elevation, was 2, deep into that Arctic air. But you go up to the base of Mount Hood Meadows at 5,400 feet, still cold, but warmer. And then you go higher. This was Saturday, real numbers here. Top of the Cascade Chair at 7,300 feet, it was 30 degrees. And yesterday, I was at Meadows, and I left the parking lot, and it was 30 degrees, and I got down to Parkdale, and it was 7. So you can get these dramatic shifts with these Arctic inversions, right? So some more real numbers and real data for you. This is a sounding or a temperature profile of the atmosphere, which was produced by the weather balloon that was released at Salem during the day on Saturday. When you see this black line go in that direction, that means it's getting warmer as you go up. That's a really steep temperature inversion. So there was this little layer here that I highlighted in red that was actually above the 0 degree or the 32 degree isotherm, meaning above freezing. How deep was it? Well, it was a really shallow layer there of 32 degree air or warmer, and it was the perfect combination to get sleet, because that layer, and I measured it, it was only 1,834 feet thick, so about 1,800 feet thick, and it went from 32 to 38 degrees. Now, to get sleet, textbook-wise, you want a layer that's no more than 2,000 feet thick, and you want it to be between 34 and 38 degrees. Nailed it. We just nailed it. That was real data in our atmosphere on Saturday. That's why we got sleet. This time around, the cold layer at the surface is much thinner, so we get freezing rain anywhere from a quarter to a half an inch in the Portland area. And again, more north and east towards the gorge, less south and west towards Eugene, because they'll warm up sooner. Pat?
All right. Thank you, Matt. Always fascinating. Appreciate it.